Mars's thin atmosphere. Watching Ingenuity rise and hover steadily, seen in flawless high definition, felt like a scene pulled straight from science fiction. But this was reality. Ingenuity completed several successful flights, each filmed by Perseverance's cameras. In the footage, its shadow stretches across the Martian ground, creating an almost surreal portrait of human invention taking flight in an alien sky. This was not only an engineering triumph, but also a storytelling breakthrough. The videos made viewers feel as though they stood alongside the rover, watching history unfold. The 4K visuals serve a dual purpose. Beyond their beauty, they assist mission planners and scientists by highlighting hazards, mapping safe routes, and pointing out areas worthy of study, such as layered rock structures or unusual formations. In effect, Perseverance has been given superhuman vision, enabling it to scan, scrutinize, and select the most valuable scientific targets. Importantly, these visuals are not limited to researchers. NASA has shared much of the footage with the public, allowing people across the globe to experience Mars almost as if standing on its surface. The clarity and detail of these images are igniting a wave of curiosity and excitement, inspiring students, engineers, dreamers, and people of all ages. From classrooms to retirement homes, the experience of seeing Mars in 4K bridges the vast distance between worlds. It transforms wonder into connection. What makes this achievement even more extraordinary is the ingenuity behind transmitting such footage. Mars lies on average about 225 million kilometers from Earth. Sending high-resolution video across this immense distance is a monumental challenge. Bandwidth is extremely limited, forcing each file to be compressed, prioritized, and carefully transmitted through NASA's Deep Space Network, a worldwide system of massive antennas that maintain links with interplanetary spacecraft. Once the data finally arrives, it undergoes a complex process of decoding and reconstruction. Imaging specialists enhance the video, correct lighting, stitch together panoramic scenes, and sometimes even apply AI to sharpen details. The outcome is more than mere video. It becomes a cinematic journey from another planet. One of the most iconic sequences showcases Perseverance exploring Jezero Crater, its designated landing site. This ancient river delta, believed to have held a lake billions of years ago, is a prime location in the hunt for signs of past life. The rover's cameras capture layered stone outcrops, distant dusty hills, rippling dunes, and fractured slabs shaped by water long ago. At sunset, Perseverance even recorded the Martian horizon bathed in an otherworldly light. The sun appears smaller than on Earth, casting a pale blue hue across the landscape, an eerie contrast to the warm orange sunsets we know. These visuals show Mars as both alien and strangely familiar. The rover has also documented dust devils in motion, miniature tornadoes racing across the plains. In 4K, one can follow the trails of individual dust particles swirling. Liquid water once again moves through the rivers, canals, channels, and even the oceans of Mars. When NASA's Perseverance rover touched down on the Martian surface in February 2021, the moment represented far more than another step in exploration. It signaled the dawn of an entirely new chapter. Outfitted with the most sophisticated cameras and scientific tools ever launched to another world, Perseverance was not designed merely to roam and investigate. Its purpose was to reveal Mars in ways humanity had never witnessed before. And now, for the very first time, the red planet can be seen in breathtaking 4K resolution. Imagery so crisp and clear that it almost defies belief. The rover's arrival was recorded by an array of high-definition cameras positioned strategically across the spacecraft. These captured every second of the nerve-wracking 7-minute descent, the deployment of the supersonic parachute, the ignition of descent engines, and finally the dramatic lowering of Perseverance to the ground by the sky crane system. For the first time in history, humanity was able to truly watch in ultra-high definition, the complete landing sequence of a craft on another world. Something once confined to imagination was now seen with our own eyes. And this was only the beginning. Once Perseverance began operations, it quickly started transmitting some of the sharpest and most vivid images ever obtained from an alien planet. Its Mastcam-Z system, positioned on the rover's head, functions like an incredibly advanced set of eyes. This system can zoom in on distant objects, create wide panoramic scenes, and even record full-color 4K video. When these visuals reach Earth, they grant an unmatched window into the Martian environment. Viewers can make out the deep red terrain, the scars of ancient riverbeds, scattered stones, and even dust devils sweeping across the horizon, all rendered in astonishing clarity. For planetary researchers, this is more than visual beauty. Each frame is a piece of data rich with clues about rock composition, signs of ancient water activity, and the weather systems still at work on the planet today. The detail is so refined that even grains of sand, the grooves of Martian stones, and the tread marks left by the rover's wheels are visible. This level of precision has transformed the study of Martian geology. Scientists can now locate promising sampling sites with accuracy never before possible. These carefully selected samples, once gathered, are expected to be returned to Earth in future missions, potentially unlocking the answer to whether life ever emerged on Mars. Adding even more depth to this sensory record is Perseverance's SuperCam. Perched atop the rover, it is far more than a camera. It combines laser technology, a microphone, and a spectrometer. The laser fires at rocks to reveal their chemical makeup, while the microphone captures the sound of each laser strike along with the haunting whispers of Martian winds. Paired with 4K video, these elements merge into a multisensory experience, sight and sound from a world millions of kilometers away. One of the most remarkable scenes recorded came when Perseverance captured footage of the Ingenuity helicopter lifting off. This small drone, the first aircraft to fly on another planet, confirmed that powered flight was possible even through the thin atmosphere. Such scenes prove that Mars is not a silent, motionless world, but one shaped by constant natural forces. Close-up footage reveals even more. When Perseverance uses its robotic arm to examine rocks or collect core samples, the cameras zoom in with extraordinary sharpness. The footage captures the drill in action, the fine texture of Martian stone, and the exact moment when sample tubes are sealed for return to Earth. These are not just scientific operations, they are history preserved in pristine visual detail. NASA's decision to equip Perseverance with these advanced imaging tools was not solely about gathering superior data. It was also about sparking global engagement. Public fascination with space has surged in recent years, and vivid 4K video from Mars transforms passive interest into active wonder. People don't simply admire these images, they ask questions. What exactly am I seeing? How was it filmed? What does this mean for our future? These are precisely the questions NASA seeks to inspire. The mission goes beyond exploring Mars. It is about preparing for human journeys and addressing one of humanity's most profound mysteries. Are we alone? Astrobiology, the study of life in the universe, lies at the heart of Perseverance's mission. By examining ancient sedimentary layers, scientists hope to find biosignatures, chemical or structural evidence left behind by microbes. The clarity of 4K visuals helps identify promising samples that might preserve organic compounds. If such compounds are discovered, they could represent proof that Mars once supported life. At the same time, Perseverance is laying the groundwork for the future. The samples it collects will be gathered by upcoming missions and returned to Earth for study, a bold endeavor never attempted before. This Mars sample return campaign is one of the most ambitious projects in the history of exploration. The high-definition imagery captured today will be essential in planning and ensuring its success. Equally impressive is how Perseverance's imaging integrates with other instruments to create a complete narrative. A rock may first be identified by Mastcam-Z, analyzed with SuperCam's laser, and then examined by the robotic arm, all carefully documented in high-definition visuals. This layered dataset unites imagery, audio, and chemical analysis into one seamless record. Such integration represents a new era in planetary exploration. It is no longer just about robots collecting numbers. It is about immersive storytelling that allows scientists, engineers, geologists, and even filmmakers to collaborate. Together, they are piecing together the story of Mars. These achievements are made even more remarkable by the harsh Martian environment. Temperatures drop below -80 degrees Celsius. Dust storms rage, and solar radiation remains intense. Yet, the cameras continue to perform flawlessly, safeguarded by protective housings engineered to endure extremes. Even sound enriches the experience. Microphones have picked up the. Equally impressive is how Perseverance's imaging integrates with other instruments to create a complete narrative. A rock may first be identified by Mastcam-Z, analyzed with SuperCam's laser, and then examined by the robotic arm, all carefully documented in high-definition visuals. This layered dataset unites imagery, audio, and chemical analysis into one seamless record. Such integration represents a new era in planetary exploration. It is no longer just about robots collecting numbers. It is about immersive storytelling that allows scientists, engineers, geologists, and even filmmakers to collaborate. Together, they are piecing together the story of Mars. These achievements are made even more remarkable by the harsh Martian environment. Temperatures drop below -80 degrees Celsius. Dust storms rage, and solar radiation remains intense. Yet, the cameras continue to perform flawlessly, safeguarded by